Okay, so we're going to finish 3.1 today. Okay. So yesterday, we completed this square to put it in vertex form so we could find the vertex. Now we're learning a different way to find the vertex when it's in standard form. So this is a little bit faster, a little bit easier. So this is when it's in standard form. This is our standard form right here. And then this is the formula. So I'll let you write it down and then I will explain it. Okay. So when we complete the square, we have that little formula that we had to, use and memorize, that b over 2 squared. Well, now when we find the vertex, we have another little formula that's similar but not the exact same. So you have to be able to keep them straight. When you want to find the x coordinate of your vertex, it's the opposite of b over 2a. And so say opposite instead of negative, because it's already negative, you want to make sure you switch it. So opposite of b over 2a. And then this second part here, this f of negative b over 2a, this is just plugging in whatever number you get here back into your equation to find the y coordinate. So on this example, we won't do the graph or the other features, but we will identify the vertex. All right, so your vertex is h and k. So h is opposite of b over 2a. So that's how we find the x coordinate of the vertex. This line right here just got copied over. It is minus 19, and that's it. Okay, so b is what? What is b? 10. So opposite of b is negative 10. What is a? Negative 1. So make sure you multiply first in the denominator. So multiply 2 times negative 1 before you divide. So we get 5. So the x coordinate is 5. Then to find k, to find the y coordinate, plug 5 back into your original function. So k is going to be h of 5. So that negative is outside the x squared. So when you plug it in, you're just plugging in 5 for x and leaving the negative outside. So you calculate that and you should get 6. That's you got? Okay, so my vertex is 5, 6. Okay. Questions about that? Okay, we're going to spend some time today talking about some word problems. And the actual calculations, the math that you would have to do, you've done before. It's not too difficult. The harder part is just knowing what each part is asking for. So we'll spend some time talking about that. Okay, take a minute to read it. Don't feel like you need to write the whole thing down. Maybe note the problem number. So this is section 3.1. This is number 42. So whenever you do a word problem, you need to know what your variables represent. So I want to know, okay, x is the number of clocks, and p of x is the profit. All right. Part A, find the y-intercept and explain what it means in this context. So y-intercept means I plug in 0 for what? X. Okay, when it's in standard form, remember, then it's just your C value because these first two terms would be 0. So your y-intercept is just 0, negative 375. Okay, so 0 is my x. So that means what? X is what does it represent? So I sold 0 clocks. Okay, so let's make that make sense here. You can say when you sell 0 clocks, but it's also before you've sold any clocks. So before you sell any clocks. All right, what's my y coordinate? What's that, and what does the y represent? It represents your profit. P of x is the profit. So before you sell any clocks, what then? If it's negative 375, what does that mean? Yeah. So before you sell any clocks, you owe 375, or you're down 375. Make sure that you have a label. Profit is money, so $375. Okay, part B. Find the x-intercepts and explain what they mean. So if you want to find the x-intercepts, you plug in 0 for what? Okay, so remember, this is where we would factor. But does this look like an easy one to factor? No. So if we can't factor, what do we use? Quadratic formula. Okay, you should have that memorized. So remember, it's opposite of b plus or minus the square root of b squared minus 4ac all over 2a. Okay, so let's plug in our numbers. So opposite of b would be what? Negative 240 plus or minus b squared, so 240 squared minus 4 times a. What's a? Negative 1.6 times c. What's c? Negative 375 all over 2a. Okay, so when you do this, calculate the discriminant part first. So what's under the radical? So do that part first. Because if it's negative, then you'll know there's no x-intercepts because we don't graph imaginary numbers. Was it 55,200? Is that what it was? Yes, 55. Okay. And then 2 times negative 1.6 is negative 3.2. Okay, this is a word problem. We're solving for x, which x represents what? Clocks. So I will round, and what would it make sense to round to? Yeah, whole number, right? Because you're not going to make part of a clock. You'll make just a whole number of clocks. So do the square root, and we'll round to the nearest whole number. And what was this answer? What was the square root? 235? Okay. All over negative 3.2. Okay, let's find our two solutions, and again, we'll round to the nearest whole number.
Excuse me, Ms. Cecil, could you please send Macy around to check out exhibit?
Yes?
Thank you.
Okay, so when you do this, do negative 240 plus 235 and hit enter and then divide, or you have to put it in parentheses, but you have to add or subtract on the top before you can divide. Round to the nearest whole number. So what did you get for the first one when you added? 2? Okay. And then the second one, like 148. Is it 148? Okay. So my two x-intercepts are approximately 2, 0, and 148, 0. Now I want to explain what they mean. So my x-coordinate represents what? The number of clocks. Okay, so when you sell, really I think it's make and sell. When you make and sell 2 clocks or 148 clocks. Oh, there we go. Then what is true? So 0 represents what? Profit. Okay, so then you have a profit of 0, or what's another way I could say that? A way you would see in word problems more. Yeah, you break even. Yeah, so let's talk about that a little bit, because I know that might seem weird, like, okay, why, if you make more clocks, you should just keep getting more profit, right? Well, our function is quadratic because eventually, for some reason, the cost to make the clocks, it brings down your profit when you get to a certain point. Okay, so after this, then you actually start, after you make past 148 clocks, you actually start losing money because the cost to make them outweigh what you would get on your profit. So on a graph, it looks something like this. So it's a parabola, right? And my A value is negative, so that means it opens my x-intercepts are 2 and 148. So something like this, where this is 2 and this is 148. So that's the graph of your profit. Okay, and then this down here is the y-intercept. That'd be negative 375 on the y. Okay, so I want to kind of still keep that picture. So then when I do the next question, what is the maximum profit? Or no, sorry. How many clocks should be made and sold to maximize profit? Okay, so here's my graph. If I want to find the maximum, what point am I looking for? The vertex. So when you're doing quadratics and it asks you to find the maximum or minimum, it's asking for your vertex. You will have to know that. You'll have to understand that's what that means. Okay, so I want to find the vertex. And it's asking for how many clocks. So I want the x-coordinate of the vertex. And then D says, what is that maximum profit? So that's profit's the y. So this one's my y-coordinate of the vertex. Okay, so my vertex I know is HK. So to find H, to find the x-coordinate, it's that little formula, opposite of B over 2A. So you have to go to your original equation. So opposite of B is negative 240 over 2 times A, which is negative 1.6. Okay, was that 75? Okay, 75. So you should sell 75 clocks to maximize your profit. And then what is that maximum profit? That wants the y-coordinate. So you're going to plug in 75 and find that y-coordinate. So negative 1.6 plus okay, and calculate that. That was, I don't remember, what did we get here? $8,625. Okay. Okay. Good. So I'm gonna make some notes here about quadratic word problems in general. Okay, so when it asks us for our y-intercept, it's actually asking us, so this said before we sell any clocks, it's really asking us for like the starting value. Okay. When it's asking us for the break-even point, it's wanting our x-intercepts. the vertex. So you might not have on the word problem, it might not specifically say find the y-intercept. It might say before you begin, how much profit do you have, or something like that. Here it might say what is how many clocks would you have to sell to break even. You have to know that's asking for your x-intercepts. And then what is the maximum number of clocks or maximum profit? You have to know that's asking for your vertex. Yes. All right. Questions about that? Okay. We're going to practice this again in just a minute. Right now we're going to work backwards and write an equation from a graph. So what's written here in blue, those are the steps to do this. Those aren't going to be given to you on the problems, but these are the steps we want to follow. Okay, so first of all, I want to find the vertex and another point on the curve. So my vertex here is -2, 1. And then I just want to choose any other point that I can tell where the graph goes through. So, like right here, that's -1, +2. I have to use that extra point to find my A value. Okay, so for step 2, I'm going to plug in my vertex for H and K, my points for X and Y, and solve for A. So that's, instead of f of X, I'll just write Y. Okay, so I'm going to plug in 2 for Y, -1 for X, -2 for H, and 1 for K. And I'm trying to solve for A. Now this one might be obvious that you can tell the pattern hasn't changed from the parent function and A is going to be 1. But the one we're going to do next, we'll have to find A. So we'll practice it now. Okay, so this ends up giving me 1. So I get 1 squared, which is 1. A times 1 is just A. Subtract 1, and 1 equals A. Okay. And then step 3, write the equation. So write the equation with A, H, and K. X and Y go back to just X and Y. So A is 1, so that means I don't have to write it. X minus -2 means X plus 2 plus 1. So f of X is X plus 2 squared plus 1. There's my equation. steps. So our vertex is at 2, -1. And then I need another point. So I'm going to pick this line, which is 0, -2. It could be any other point that's on the graph, though. Okay, plug those in for h, k, x, and y to find A. So what is something I know has to be true about A? Something maybe really obvious. Yeah, it's going to be negative. It's going to be negative, and then less than 1 maybe is because it's wider, but negative definitely 2 because it's reflected. Okay, so those are things to think about when you're doing this. So I'm going to plug that into this equation. Okay, so when I do 0 minus 2 squared, I get 4. So that's 4a. If we add 1, I get -1. Divide by 4, and I get 1/4 for a. -1/4, thank you. -1/4. See, again, knowing in my head at the beginning it needed to be negative would have helped me find that mistake when you're working these out. Okay, so think about those things. Okay, so I plug in h, k, and a. So you can either write y. If it doesn't tell you, you should use f of x or y. Okay. Questions about that? Okay. We just talked a little bit about like our x-intercepts and about solutions because as we continue in this chapter, we're going to be finding more than just 2 x-intercepts for different polynomials. So proper notation is pretty important. So all of these are basically the same thing, but there's just different ways to write it. So R0 is an x-intercept. So if it asks you for an intercept, you should be finding a point in ordered pair. But just x equals R is the solution or root. So x equals R is a solution, a root, and also a 0. So that R is 3 different things that, well, 3 things that mean the same thing, 3 different words. Solution, root, 0. All of those are the same. Then if we write this, when we factor, x minus r is the factor. That gives us the x equals r as the 0. let's look at another word problem, and we will go through these as well. So again, if you want to just note the problem number, again, this is section 3.1. Three point one, number 44. So take a minute to read it. Also read through A, B, C, and D, so we kind of know what we're finding. We're going to be able to combine A and B. So take a minute to read through the whole thing first. Okay, so A says find the lowest cost of a ticket that would allow the club to break even. So break even, what does that mean? Interpretation on a graph. What was it? I think I heard it, but then I wasn't sure. What? X-intercept. X-intercept. Okay. B also says break even.
I still don't get that. If you make a lot of money, how you break even again?
Well, so this is a quadratic profit equation. So, you know, the people at this company, someone sat down and figured out this profit equation for them. So that means on a graph, it's going to look something like this. Okay? Because they're taking into account the cost that it makes, the cost it takes to do these things. So the cost to do this performance. And eventually, the costs are going to become too much, so you start losing money. So let's say that if the ticket, X is our ticket cost of a ticket. So let's say the cost of the tickets, the more that they cost, then they're saying that for some reason that's going to make the cost to do the show more, and that might be because like the number of clocks I think makes more sense, because if you make more clocks, you have to hire more workers and do things like that, so your costs will go down. But here, so for some, the rise in the cost of the tickets eventually is going to make you start losing profit and then eventually go in the hole if you build more. So this part here, that doesn't necessarily mean those are your minimum and maximum. That's your domain, your minimum, maximum, X value, but that doesn't necessarily mean that's where your X-intercepts are. Those are saying these points here. Like this would be your 0x, your 50x, okay? But A and B are asking us for our X-intercepts here and here. Does that make sense? Okay. All right. Then C says, if the theater were to close down before any tickets are sold, how much money would the club lose? So what part of the graph is that asking us? The y-intercept, that's the starting value. Okay, so before you sell any money, that's the starting value, so that's asking us for our y-intercept. Okay. Part D says, how much should the club charge to maximize their profits, and then what is the maximum profit? So what part of the graph is that? Vertex. Good. So maximum is vertex. Okay. So we'll do A and B together because those are both the x-intercepts. So if I want the x-intercept, I plug 0 in for y. So solving for x means you're either going to factor or use quadratic formula like we did in the last problem. This one does factor, so it's a little bit easier. But before we factor, you want to pull out that negative. So you want to pull that negative out. So that's basically factoring out a -1. And what happens when I divide both sides by that -1? Yeah, it just cancels out. So I'm solving this. If you don't feel comfortable with that factoring, you can always use quadratic formula and then you don't have to change anything. But now that we have a setup like this, it's not too bad. So I need numbers that multiply to give me 88 and add to give me -46. Good. -44 and -2. So x is 44 and x equals 2. So back to the proper notation we just saw, these are the roots, solutions, and zeros. Right here, x minus 44, x minus 2, those are the factors. But then the x-intercepts are the ordered pairs. Okay, so then if I can answer A and B now. So the lowest price for the club to break even would be, okay, 2, and we're talking about price, so $2. And then the highest cost, 44. Good, $44. Okay, part C. If a theater were to close down before they sold tickets, how much would they lose? So that was the y-intercept. Remember, y-intercept, go back to your original function. When it's in standard form, it's just our c value. So what's my y-intercept? Okay, so my y-intercept was 0, -88. So then to answer the question, what would I say? Lose $88. So it's important to keep that word lose, so we're not thinking it's positive 88, but we're not going to say negative $88. That doesn't make sense. So lose $88. Okay. And then D, we're looking for the vertex. So how much did the club charge to maximize their profits? That's what coordinate of the vertex? X, and then the maximum profit is the y. Good. So we're going to find x and y on this problem. So our vertex is HK. I need to use that little formula for H. Opposite of B over 2A. Again, go back to your original function. So on part A and B, here we had changed it, but that's only because it was equal to 0. All right, so we can only change, we can only factor out and divide that factor off if it's equal to 0. So I got to go back to my original, which is this. So opposite of B is -46 over 2, and A is, okay, good. Make sure you multiply first. We should get 23. And And then how do I find the y coordinate? Plug 23 back in. Okay. So p of 23 plus 46 times 23. What was it? Minus 88, thank you. So going kind of fast now, so we make sure we can get done. And was it 441? Everyone gets a chance to calculate 441. Okay. So last little bit here, answering these two questions. So how much should they charge to maximize their profits? $23. And what is the maximum profit? Hold on, we gotta talk about this. What's the maximum profit? 441, but if we know from the very beginning, the profit is in hundreds. So what do I have to put with that 441? 100, so 2 zeros. So pay attention to those things. Okay, so that's all of 3.1. 3.1 quadratics. Tomorrow, we're going to start dividing polynomials, long division. Yay!